Okay guys, welcome back. So this is in this video I'll be talking about another example on the conservation of linear momentum. So as I said in the last video, I will combine the projectile motion with the conservation of linear momentum. So I'll take a simple example like this. Right? Now this is an example in which there is some hill-like surface here, right? Right. So there's a surface, and there's the cannon is being fired from here. Right? The cannon is being fired from here. With an initial velocity of 100 meters per second, and this inclination I will take as 60 degrees. So this is 60 degrees, and this goes at a speed of 100 meters per second. 100 meters per second, so that's the speed of the bullet or the cannon. So I'll take this displacement to be 20 meters. So I'll take it as 5 meters. Yeah, 5 meters. 5 meters precisely. And the height to be 10 meters. Alright, so and what the problem is that there's another ball here which is stationary, and I think this object will have mass 2 kilograms. The cannon is 2 kilograms in 2 kilograms of mass, and this mass is 4 kilograms. And when the cannon goes like this, goes like in a projectile here, because the gravity is acting upon. Right? Goes in a projectile like this. Like that. Right? And meets this cannon, meets this object. Now consider that this won't fire back, this won't explode. Right? This object and the composite moves together in this direction, in some direction. Right? So what we actually have to find is the final velocity of the composite. Now to find the final velocity of the composite, we have to find the initial velocity of the cannon. Now initial velocity of the cannon is given 100 meters per second at an angle of 60 degrees, measured counterclockwise from the horizontal. That's the initial velocity when the cannon was fired. So we don't need a velocity, we need actually. So what we need actually is not that velocity, it's the velocity at which this cannon hits this object. Now this velocity is not equal to 100 velocity, 100 meters per second, because this is not a horizontal motion. This is the horizontal velocity stays the same, but the vertical velocity or the velocity that is acting on the happening on the vertical direction will not be 0. So we have to find the vertical and horizontal velocity, and we have to find the direction as well before this cannon is been collided with the 4 kilograms. So to understand that, we have to find first whether the velocity is horizontal, the velocity is vertical, or velocity is inclined. Now in projectile motion, you know that the velocity can't be vertical. Velocity will be either horizontal, or velocity will be either horizontal, or velocity will be inclined to some angle. So to find out whether the velocity is horizontal, we have to find out whether 10 meters is the maximum height that is achieved by the object. So at the maximum height, the horizontal velocity will be 0. So the only velocity is horizontal, the vertical velocity will be 0. So the only velocity that will be acting upon the object is the horizontal velocity. So the velocity of that object at the maximum height is horizontal. So the direction will be horizontal. So we need to find out whether 10 meters is the maximum height or 10 meters is less than the maximum height. So to find the maximum height, I can put S equals ut plus half at square, but we don't know the time. So we need at the maximum height we know that the vertical velocity is 0, and we know that the initial vertical velocity, which is u, and we know g, so we need h. So we can put v. I'll take this position as a, and take this position b. B is the position of the ball, right? B is the position of the ball. This is a, and this is b. From a to b, I can put b squared equals u squared plus 2s to find s. So b squared equals u squared plus 2as, right? In the vertical direction, v squared equals u squared plus 2as. So v squared will be 0 equals u squared will be not 100 sine 60, 100 sine 60 is square, and the gravity will act downwards, so g will be minus, so it will be minus 2gh, so that is minus 2g. I'll take the maximum height as h. So 2gh is equal to, actually g, I'll take g as 20, so 2gh is equal to 20h. So 20h is equal to 100 square, that is 100 times 100, I will take it because it is easy to simplify. Sine 60 square is root 3 by 2 square, that will be 3 by 4. So here is 5. So h will be, this is 25 times 5 times 3, so 25 times 5 is 125, 125 times 3 is 375. Alright, this is a very huge maximum height. So you know that the maximum height will be 375 meters, so the maximum height is greater than 10 meters. So the maximum height will, now the height of the object at which this collides is 10 meters, the maximum height will be somewhere here, right? So the velocity of this object, now this is less than maximum height, and we have to find out whether this is on the returning journey or on the departure journey. Departure journey means the journey that is between the initial position and the maximum height, and the returning journey is the motion of the path of the object between the maximum height and the final point. So we need to find out whether this is after the maximum height or whether this is before the maximum. So to find that, we can find the distance from, we have been given that the distance from A to B is 5 meters, the horizontal distance. We can find the horizontal range of this function and then divide by 2. So if we divide that by 2, we can say, we can find out the distance between constantly, yeah, it's the best thing. The best thing is to do, we can find the distance between the maximum horizontal range and we can divide by 2. So that will be the distance between the initial position and the maximum height, the horizontal distance between the initial position and the maximum height. So we can find out whether that distance is greater than this one or equal to this one, or it can't be equal because it is not at the maximum height, whether it is greater or smaller. Depending on that, we can find the direction of the velocity. That's very important to find, to put the conservation of linear momentum, the direction of velocity. So you know that r equals v square sine 2 theta by g. That's a derivation actually. If the velocity of the object is v, the angle between the velocity and the horizontal direction measured counterclockwise is theta. So we can find out the value of r directly from here without substituting, without going through the linear equations of motion. So that will be easy to solve. So v is equal to 100 square sine 2 theta. So theta is equal to 60. So 2 theta is equal to 120. Sine 120 is equal to sine 60, which is root 3 by 2 divided by 10. Alright. So this is 100 times 100 divided by 10. The 100 is 10,000, 500 root 3. So this will be r equals 500 root 3. So the distance between A and the maximum height will be half of this one. So the distance between the maximum height and distance between the initial position and the maximum horizontal distance between the initial position and the maximum height will be half of 500 root 3, which is 250 root 3. So 250 root 3 is clearly greater than 5 meters, which is the distance we have been given. So we know that this is on the journey between the initial position and the the maximum height. So the velocity of this object is positive in the upper direction, the vertical velocity, and the horizontal velocity is still in the right direction. So we have to find the horizontal velocity, the vertical velocity. We know the horizontal velocity doesn't change in projectile motion. We have to find the vertical velocity at the time of collision. So we can say we know that the distance it travels here, right? This distance has been given 10 meters. We don't need to substitute that. We know the horizontal distance it has traveled. We know the horizontal velocity. We can put s equals ut plus half at squared in the horizontal direction because the acceleration will be 0. So we will minimize the terms that we have to substitute, and it will be easy to solve as well. So I can put from A to B. I can say s equals ut plus half at squared in this direction. Right? S equals ut plus half at squared. So s is equal to 5. S is equal to 5. So u is equal to 100 cos 60. So 100 cos 60 is half. So 100 times half is 50 times t. Right? 5 equals 50 times t. So acceleration will be 0. So half at squared is 0. So 5 equals 50 t. So t is equal to 0.1 seconds. So t is equal to 0.1 seconds. So the initial vertical velocity of the object is 100 sine 60. So we need to find the final vertical velocity of this object. So we can put v equals ut from A to B in the upward vertical direction, the upward direction. So from A to B, you can say v equals u plus at in this direction. Right? V equals u plus at from A to B. So the final velocity is v. Initial velocity is 100 sine 60. So sine 60 is equal to root 3 by 2. So 100 sine 60 will be 100 times root 3 by 2. So that is 50 root 3. Root 3 is equal to 1.7. So 100 root 3 will be approximately 50 root 3 will be approximately 85. So this is 85. Minus, because the gravitational acceleration is acting against this motion, g is 10 times the time taken is 0.1. So this will be 84 meters per second in this direction, 84 meters per second. Now we will have to find now we know this is 84 meters per second. So we have to find what is the direction of this composite, right? So we can draw the normal momentum theory here. So the initial momentum of this object is somewhat we are in this direction because it has a positive v in the vertical direction and a positive v in this direction. So we will be in this direction, and this collides with so this mass is given as 2 kilograms. This collides with a mass of 4 kilograms, assuming that there is no explosion because there is a cannon, right? So there will be some momentum, there will be some impulse. So I will not draw the impulse. Well, straight away write this question says that these two masses will go as a composite, so the mass will be 6 kilograms, and the velocity I will take as v, and this angle as theta. This angle is theta. So I want to find v and theta. So I can put the conservation of the total external force on the system is 0, so I can put the conservation of linear momentum. So that's the only thing I can find put to find V and theta. So in the horizontal direction I will put that. So this angle is some angle alpha, right? This angle is alpha. I will take VR alpha. So VR cos alpha is actually, we have found 100 cos 60, so that is 50. 50 times 2, so this is 0, will be equal to 6 times V cos theta. So we can simplify this. So this is 100, this is 6, so 100 divided by 6 is 50 by 3. So V cos theta is equal to 50 by 3. Right? Because theta will be 50 by 3, so that is in this direction. And in the vertical direction, this is 2 VR sin alpha. So VR sin alpha, we have found VR sin alpha is equal to 84. Right? VR sin alpha is equal to 84. So the momentum in that direction will be 2 times 84, which is 168, equals 6 times V sin theta. So 6 times 12, 48. So there is 2 and 8. So this is 28. V sin theta is 28 in this direction. So you know V cos theta is 50 divided by 3 in this direction, and V sin theta is equal to 28 in this direction. Now you can divide V sin theta by V cos theta and find tan theta, and then take the tan inverse. So tan theta is equal to 28 by 50 divided by 3, so that will be multiplied by this, so 84 by 50. So that will be, theta will be tan inverse 42 by 25. So similarly, theta will be tan inverse 42 divided by 25, so theta will be greater than 1, so that will be, so the angle will be greater than 45 degrees, between 45 and I don't know whether this is greater than 60 or something, but it will be, however, greater than between 45 and 90 degrees. So we can find V as well. So now I will not find the value of V. So that's how a complex problem in which the projectile motion and the conservation of linear momentum can be combined to make a problem and then solve. So in the next video I will explain to you about another new concept on conservation of linear momentum, and thanks for watching this video and see you there.